Number 13, it says you are given the task of testing the following hypothesis by first completing the topic and research question. It says the researcher was interested in analyzing whether or not there was an association between major and performance in mathematics. For this objective, the data is represented in the following table. Okay, so a researcher was interested in analyzing whether or not there was an association. So the keyword there is an association. So this is clearly a chi-square test for no association. That's the name of the test, eh? Chi-square test for no association between major and performance in mathematics. These are the two variables, your major and your math score. So the research topic would be major and academic performance in mathematics. All right. And research question, is there an association between major and academic performance in mathematics? Remember, that is the classic structure of any research project, the topic and the research question. Cannot have a research project without a research question. That's a rule of thumb. Okay. And now, with the research question now comes a hypothesis. Someone said an educated guess. Come in pairs. So one person saying no, there's no association. Another person saying yes. The one that's saying no is the HO. The HO always says no association. Please bear that in mind because that's the name of the test. Okay, so for the chi-square test for independence, you can say independent. That's another way to say it. There is the two variables are independent of each other or no association. That's what the HO will be saying. And the HA person now will be saying dependent. There is an association. So the test has to be done to see who is correct, which hypothesis is correct. That's why it always comes in pairs. Anytime you're doing a hypothesis test, the statements must come as a pair, one contradicting the other. So the test has to be done to see who is correct. So for the chi-square test for no association, the HO will be saying no association or independent. And the HA will be saying yes, dependent on each other. And that's how you begin. Okay, now we're doing a critical value approach. So we need a curve. Here we define what is variable A and B because in the text, it comes general A and B. So you have to define what is variable A and B. It doesn't matter who you put for A or B. It doesn't matter once you list them. So it's math score and major. Now steps 2, 3, and 4, we know about the curve. Screw to the right, rejection region is on the right, and the critical value on the critical point. The critical value will be provided. What is the critical value here? 3.841. That's the critical value here. 3.841. Okay, so now for step number 5, to calculate the test statistic, here's the formula. It's the same formula for all chi-squares. O minus E all squared over E, the sum thereof. Now the O now will be the values that you observed. So to test to see whether or not there was an association between score and major, a test was given to some students, natural sciences and social sciences. Okay, those are majoring in natural sciences, those are majoring in social sciences. 61 of the natural sciences got below 60, whereas 89 got below 60. 99 of the natural sciences got more than 60, 81 got more than 60 for the social sciences. So that's what you observed. So the numbers that will be given in the chi-square test for no association will be the observed values. So you have to calculate the expected values. Here is the formula to calculate the expected values. Row total times column total divided by grand total. What do we mean by row total? You have 61 and 99. 61 plus 99 is 160. That will be the row total. Okay? That will be the first row total. The next row total is 89 and 81. 89 plus 81 will give us 170. So these are the row totals. The column totals, you have to add 61 and 89 here. 61 plus 89, that will give us 150. And the other column total, 99 plus 81, that will give us 180. So these are the totals. And the grand total now, you add the subtotals either horizontally or vertically to get the grand total. So 160 plus 170 will give us 330. 150 plus 180 will give us 330. So that's the grand total right there. All right. So now to calculate the expected values, the row total. So for example, each observed will have their own expected. So for 61, it will be the 160 because that's its row total times 150 divided by the grand total 330. Okay. 160 plus 1 times 150 divided by 330. And that will give us the expected value for 61, 72.73. You do the same for 99. The row total for 99 is 160, but the column total now is 180. So 160 times 180 divided by 340, 87.27. We go to 89. The row total is 170. The column total is 150. So it's 170 times 150 divided by 330, 77.27. Now we go to the 81. The row total is the same 170, but the column total is 180 now. 170 times 180 divided by 340 will give us the expected for the 81. So here we have the observed. These are the values that were given. These are the values that were provided. You will be provided with the observed values. You will be provided. You see like how the table comes, exactly how you see it, that's how it will be provided to you. Okay, so all you need to do now is to calculate the expected values using this simple formula. So now we have the observed and we have the expected. We can do our O minus E all squared over E according to what this formula is saying, so that we can find the sum. We have a setup already in Excel. Okay, we have a setup already. We have it programmed already. All we need to do is to put a new set of values of O and E's. Here we have our O's and E's. Here they are. $61 is the first O. And its E is 72.73. 99 is the next O. Its E is 87.27. All right. Next O is 89. Its E is 77.27. The next O is 81, and its E is 92.73. And here we have our chi-square contributions, 4 of them, and the chi-square test statistics is 6.73. Okay, so now we can easily copy this and paste it in our workings. So here we have it. Control C. Control V. Part of step number 5. There it is. So that's our test statistic, 6.73. So we have to go back to the curve. and compare it with our critical value. Do not reject, reject. Do not reject, reject. 6.6. We can't put 6 there. We cannot put 6 there. 6 is greater than 3 on the number line. Anywhere around here. So clearly you can see the test statistic is in the critical region. What you can do, you can go to home, you can go to select, select objects, select this, and you can shift, right click and group it up so it can make one image. All right, so it wouldn't go all over the place when you know, when you're doing your stuff. So again, our test statistic is in the critical region. All right, our test statistics is in the critical region. So when this happens, we have to reject the null. So I'm just grouping this up there just to show you how it can be done. So you can do that on your own time. So let's go back to where we were. We got 6.73. 6.73 is greater than 3, so we have to reject the null. Here, remember, we're starting with 2 statements. We are testing hypotheses. The question was asked, is there an association between major and score? Here is the question. So we have to try to answer that question. There are 2 possible answers. One saying no, one saying yes. So we reject the one that say no. According to the results, we have to reject the null hypothesis. So we have to keep the alternative as our conclusion. Okay, it's always about the null when you're rejecting or not. Okay, please bear that in mind. Remember what step number 7 say. Step number 7 say, okay, reject the null if the test statistic is in a rejection region. Do not reject the null. So it's always about the null. It is either to reject it or not to reject it. So since the test statistic is in a rejection region, the decision is to reject the null. Since the null hypothesis was rejected, then the alternative statement is the conclusion. Therefore, based on the data that was observed, let's go and quote what the alternative is saying because we rejected the null. There is an association between what are the variables, mathematics score and major. So there is an association according to the data, based on the data. Based on the data that was observed, there is an association between major and academic performance in mathematics. All right. So here you have it. Chi-square test for no association using the critical value approach.